Okay, so before I start with the questions in this video, I just want to do a quick recap on this chapter so far because we actually have everything done now in this chapter that we need to do. So the first thing is the three forms of equations. So you can get an equation in this format here, x squared plus y squared is equal to r squared. Here's an example. Okay, and what you need to know from this formula, as we've seen, is that if it's in that, we know that the center is always going to be on 0, 0, and this is r squared, so we know that the radius of that circle needs to be 5. Then you can get it in this format here, where the center is hk and the radius is r, so that would mean that the center of this circle here is 7 minus 3, so you change the signs, and 10 here, so this stands for r squared, so the radius would have to be the square root of 10. Okay, and then finally then you can get an equation in this format here. Okay, here's an example. So to get the center of this circle here, you divide by 2 and then you change the sign. So that would be minus 5, 2. And then as we've seen loads of times now at this stage, to get the radius, if it's in this format, you have to use this formula here, g squared plus f squared minus c. Okay, where your g is minus 5 and your f is 2 and your c there would be 3. Okay, then we had a look at where a circle cuts the x and y axis. So to see where a circle cuts the x axis, you let y equal 0, and to see where a circle cuts the y axis, you let x equal 0, and you will usually get a quadratic. It makes sense that you get a quadratic because if you think about it, right, if we have a circle here, when it cuts the x-axis, it's usually going to cut it twice. And it cuts the y-axis, it's also usually going to cut it twice. Okay, so that's why it makes sense that you get a quadratic, and from your quadratic then you're obviously going to get two different answers. Okay, and circle cutting the x and y axis, that was video 5. Then we went on to whether to figure out if a point is inside, outside, or on the circle. So you sub the point into the equation. Okay, and that was video 6. And then we went on to how to find where a line and a circle intersect each other. Okay, so that's kind of revision because all you do is simultaneous equations, one linear, one non-linear, and that is all pretty much done in 5th year. And it was also on video 7. Okay, and then finally the video that we did yesterday was touching circles. So if they touch externally, d is equal to r1 plus r2, but if they touch internally, d is equal to r1 minus r2, and d is the distance between the centers. And just remember, these two formulas here, they're not in the log tables, so you need to know them. And then just a couple of other important points here just before we move on. So to find an equation of a circle, what two things do you need? You need the center of the circle and you need the radius of the circle. Another important point here that we will be looking at and that we've seen as well, if you have a tangent, what is a tangent? A tangent is a line that cuts a circle once or touches a circle once. If you join the radius and a tangent, it is always going to be a 90-degree angle. Okay, and this here is the radius. But to find the radius in that situation, right, we could actually use this formula here, and we've done this before, ax1 plus by1 plus c all over the square root of a squared plus b squared, because the radius there would be the perpendicular distance from a point to a line. So just bear in mind that formula there as well. And then finally then, this chapter uses other formulas as well. So we've used the distance formula, we've used the midpoint formula, we've used the slope formula. I just talked about this formula up here, it comes up quite a lot. And then finally then, if we're getting quadratics, then you need to be able to solve a quadratic, and also maybe the minus b formula might come into it. So that's just a quick recap on everything to do with this chapter. Okay, so we're going to have a look at this question now. So this is a typical Leaving Cert question that they like to put up. So find the equation of the circle that passes through these 3 points here. So all they give you is 3 points that the circle has to pass through. So I just drew a diagram down here. So here are the 3 points, all right, and we need to find the equation of that circle there, okay? So the first thing that I would say to myself here is, well, what are the 2 things that we need to find the equation? So the 2 things that you need to find the equation of the circle is you need the center, which we don't have. We have no idea what the center is. And we also need the radius. And we also have no idea what the radius is either. So we're a long way away from having this question finished at the minute, because we don't know the only 2 things that you need to find the equation of a circle. Okay, so before we start into this question, there is a geometry formula that will help us. So if we have a circle, okay, and then if we have a line like this, now a line like this is called a chord. It touches the circle or intersects the circle twice. Now, the geometry theorem is that if you get the midpoint of the chord, and I'll call that M, so that's the midpoint of the chord, and then obviously that distance is now the same as that distance. And then if you draw a line perpendicular, so perpendicular there, okay, and if I was to call that the line L1, all right, this line must pass through the center. So the center must be somewhere along this line. Okay, so we're going to use that theorem now to solve this question here. So as you see in here in red, I have joined A to B. So this is my chord, okay? And the first thing now, the first step that I need to do is I need to find the midpoint of this chord here, okay? So I'm finding the midpoint between 1, 1 and 2, 3, and I'm actually not going to do it, I'm just going to skip it. So obviously you would use the midpoint formula, and if you do find the midpoint between these 2 points here, your answer is going to be 3 over 2, 2. So that's your midpoint there, that's 3 over 2, 2. Okay, so that's going to be your midpoint. And then if I draw a perpendicular bisector going down here, okay, as we saw in the theorem, this line here must pass through our center. Okay, so what I want to do is I'm going to find the equation of this perpendicular bisector going down here. Okay, so how do we find the equation of a line? So the first thing we need is a point on the line, which I have, and the next thing I need is I need the slope of this line here, and I don't know the slope of this line here, but if we remember, if I find the slope of this chord, then I can get the slope of this line. So the slope of this chord here is 2. Again, I found that by using the slope formula. So the slope of this chord here is 2. So therefore the slope of this line going down here needs to be minus 1 over 2. All right, because if they're perpendicular and you have one slope, you turn it upside down and change the sign to find the other slope. So now for this line here, okay, I'll call it L1. We have a point on the line and we have the slope of the line. So now I can find the equation. You would obviously use this formula here, y minus y1 is equal to m bracket x minus x1, and you would find the equation of this line here. So the answer turns out to be 2x plus 4y is equal to 11. So that is the equation of that line here. Okay, so I did a lot there, so I'm just going to recap what I did. So the first thing I did was I drew the chord between A and B, and I found the midpoint, which was 3 over 2, 2. The next thing then, I just drew a perpendicular line going down here, and the theorem tells us that the center needs to be on this line here somewhere. So what our aim is, it's to find the equation of this line. So to find the equation of a line, the two things you need are a point on the line, which I have, but you also need the slope of this line. We don't know the slope of this line, so instead I found the slope of this line using the formula. So the formula is y2 minus y1 all over x2 minus x1. So I found the slope of this line, which is 2. And then, as we've seen before, to find the slope of the perpendicular line, you turn it upside down and change the sign. So now the slope of this line here, okay, is minus half. So once I know the slope and once I have a point on the line, I was able to use this formula here to find the equation. So now I have the equation of this line here, and it's called L1. Okay, so what I want you to do now is to repeat the process with B and C. Okay, so if I draw a chord between B and C, okay, so I'm going to get you to repeat the process. So you can find the midpoint, M, between B and C, okay, and then once you find the midpoint, you can do a perpendicular bisector like that, okay. Find the equation of this perpendicular bisector exactly as I did down here, okay, and then the center must also lie on this perpendicular bisector. We can call that L2. So now you know that the center must lie on L1 and the center must also lie on L2. So to find the center point, you would just do simultaneous equations between L1 and L2. So pause this video now and see, can you finish it off by yourself? Okay, so to finish off this now, we want to find the equation of L2. So the first thing we would need to find is the midpoint, okay, between B and C. And again, you would use the midpoint formula there, and the answer should turn out to be 2, 0. Okay, the next thing then you need to find this equation here is you need to find the slope of L2. But we can't find the slope of L2, so instead we find the slope of our chord, which is BC. So the slope of the chord, okay, turns out to be -1. All right, so then the slope of L2, if you like, -1 is really -1 over 1. So if you turn that upside down and change the sign, the slope of this here will just be 1. Okay, so now we know everything we need to find the equation of this line here. We have a point on the line and we know that the slope is 1. So once again, you would use this formula here, which I'm not going to do. It's junior cert maths. Okay, so you would use this formula here to find the equation of L2, and the equation of L2 turns out to be x minus y is equal to 2. Okay, so now we know the equation of L1 and we know the equation of L2. We know that the center has to be on L1. We know that the center also needs to be on L2. So the center must be here where L1 and L2 intersect each other. Okay, and in maths, how do you find the point of intersection? Well, you have to solve simultaneous equations between L2 here and L1. So that's the next part that we have to do. So again, I'm going to write down L1, which is 2x plus 4y is equal to 11, and L2, which is x minus y is equal to 2. We would solve simultaneous equations here. So I might multiply all that there by -2. Okay, again, this is just junior cert simultaneous equations. So it's going to be 2x plus 4y is equal to 11, minus 2x plus 2y is equal to -4. They're going to go, we're going to get 6y is equal to 7. So y is equal to 7 over 6. Okay, and then to get x then, well, I do know that x minus y is equal to 2. So x minus, but y isn't y anymore, that's 7 over 6 is equal to 2. So then finally then x will be equal to 2 plus 7 over 6. So finally then x will equal, just did it on the calculator, 19 all over 6. Okay, so that means, okay, that our answer to the simultaneous equations is the x value is 19 all over 6 and the y value is 7 over 6. So that means now that if I go back here, that the line L1 and L2 intersect at that point there. So the answer there is 19 over 6 and 7 over 6. So that is my center. Okay, so if I go back up here now I actually do know the center. Okay, it is 19 over 6 and 7 over 6. So I'm halfway there now. I have my center. The only thing I need now is the radius. Okay, but I'm hoping now that this is quite clear, because if you think about it, the radius is going to be the distance between here and there, or it could be the distance between here and there, or it could be the distance between there and C. So to find the radius now, you just need to use the distance formula to find the distance between here and there, or there and there, or there and there. So it's really just using the distance formula. Okay, so the radius then, if you do that, and if you do use the distance formula, the radius is turning out to be the square root of 85 all over 18. So that is the radius of the circle. So, okay, so if we recap now all our information, we know that the center has turned out to be 19 over 6 and 7 over 6, and we use the distance formula to find the radius, which turned out to be the square root of 85 all over 18. So now we know the center and we know the radius, so now we can actually finally answer the last part of the question, which was to find the equation of the circle. So now we're actually in a position to answer the question and to find the equation. So once again, we know the center, we know the radius. Okay, the center is not on 0, 0, so we're not going to be using this formula, okay, because that's only for a circle whose center is on 0, 0, so we're not going to be doing that. We're going to be using this formula here, x minus h to be squared plus y minus k to be squared is equal to r squared. Okay, and then h and k is the center, so we know it's going to be x minus 19 over 6 to be squared plus y minus 7 over 6 to be squared is equal to the radius squared. But if I square that, I'm just going to get 85 all over 18. So finally now, my final answer, I now know that the equation of this circle here is this answer here. Okay, so if we look at the diagram here, there's quite a lot going on here, okay? But I'm going to give you a practice question to do to see if you get it. Okay, so here is another question. Now, this video is probably too long already, so I'm not going to do the question out exactly. I'm just going to show you what to do, okay? And you can see here it is question 2 on page 315. So here the situation is they give you a circle, okay? We have the point P and Q, which is on the circle. And then they give us the equation of a line here, x plus y is equal to 3. And this is the line going down here. And they tell us in the question that the center is on this line. Okay, so we know that the center is on this line. And once again, like all these questions, they are asking for the equation of a circle. Okay, so once again, what are the two things you need to find the equation of a circle? You need the center and you need the radius, both of which we don't have. Okay, we don't know where the center is. We know it's on this line somewhere, but we don't know where the center is, and we have no idea what the radius is. Okay, so this question is actually very similar to the other question. It's actually shorter. Okay, so we follow the same routine. So we make a chord. So you would join that to that. Okay, and then you would find the midpoint here, M. Okay, so you would use the midpoint formula to find this point here. Okay, and now I'm just going to draw in the perpendicular bisector. So again, that's the same as that. And remember about this line here, L. Okay, this line, the center must also be on this line. Okay, so what you would do is you would find the equation of this line. All right, okay, the same way. So you have a point on the line because you will know what this point here is. All right, and you will also know the slope because you find the slope of this line. Okay, you turn it upside down and change the sign, and now you have the slope of this line. So you have your slope, you have your point, and now you're able to find the equation, just like in the last question. And now you have this equation, okay, and you know the center is on this line, and you also know the center needs to be on this line. So just like in the last question now, you're going to solve simultaneous equations between whatever answer you get here and x plus y is equal to 3. That will give you your center. Okay, so now you will know your center. And then to find the radius, it's the same. The radius is just going to be the distance between here and P, or there and Q. And that will give you your radius. Once you have the radius, then just like in the last question, x minus h to be squared plus y minus k to be squared is equal to r squared. You fill that in and you have your question done. So it's quite a long question, but I'm not doing it all out. Okay, but that is how you would do it. I would advise you to do it. The next one, which is a very, very good one, okay, is this question here. So once again, this is in your book. I'm not going to do it all out fully, but I'm just going to show you what to do. So it'll be page 315, question 11. Okay, so look at this thing here. So once again, they give us a circle. They tell us A here is a point on the circle, is 2 minus 2. And then they tell us that this point here, okay, is a tangent. And they tell us the equation of the tangent, all right? And a tangent cuts a circle just once, and it's hitting the circle at this point here, okay? 5 minus 5. Okay, and once again, they are asking for the equation. So once again, the two things that we need to find the equation of this circle, we need the center and we need the radius, once again, both of which we don't have. All right, so we just need to use now what we know about this chapter to find the center and radius. Okay, so the first thing we can do is what we do usually. So this is the third time now you would have seen this. So we have 2 points. So we can once again join those two together. Okay, you can find the midpoint using the midpoint formula. Now you can draw the perpendicular bisector up there. Okay, once again, I'm going to call that L. All right, and we can find the equation of L. Okay, once again, you have a point on the line and you can find the slope because you find the slope of this line here. You turn it upside down, change the sign, and now you have the slope of this line. Once you have a point and the slope, you can find the equation and you can write it in that box there. So now you have the equation of, we'll call it actually L1. Okay, now we have this here. Okay, but once again, there is a theorem in geometry that says that if you have a tangent, okay, the radius must come up 90 degrees there from any tangent. So this line here that I'm drawing up here, okay, I'll just extend it all out. I'll call that L2, okay. That line must also pass through the center, all right. So L2 now must also go through the center. So what we would do is we would find the equation of L2, okay. So once again, to find the equation of L2, what do you need? You need a point on L2. Do we have a point on L2? Yes, B is a point on L2. Okay, so what's the other thing we need on L2, or what's the other piece of information we need about L2, is we need the slope. So how would you find the slope of this line here? You know it's perpendicular to this line. So we need to find the slope of this tangent here. But again, it's all coming back to the other chapter, because remember, isn't this in the format ax plus by plus c is equal to 0. Okay, it is in that format if I just brought the 35 over. And then remember, I told you that the slope, if you have the equation of a line, you can actually find the slope. It's equal to minus a over b. So the slope of our tangent there is minus 3 all over b, which is minus 4. And then a minus divided by minus is always a plus. So the slope of our tangent here is actually 3 over 4. So doesn't that mean then that the slope of this line is minus 4 over 3? So now for L2, you have a point on L2, it's 5 minus 5, and you have the slope, it's minus 4 over 3. So now you can find the equation of L2. All right, so you know the center is on L1, you know the center is also has to be on L2. So how do you find the center? You have to get the point of intersection between L1 and L2. So you have to do simultaneous equations here. That will give you your center. And then once again, how do you find the radius? Well, the radius could be the distance from your center out to A, or your radius could be from your center out to B. And so you're just using the distance formula. That will give you your center and you will have your radius. And once again, you can throw it all into the formula x minus h squared plus y minus k to be squared is equal to r squared. And that will finally give you your answer.